Okay, so here's a problem we talked a little bit about. We've already noticed that it's a stable and determinate structure, and it's our job to find all the forces in the trusses, or in the truss. So far we just had method of joints, so we're going to look at writing our equations of equilibrium at each of the 1, 2, 3, 4, 5 joints, right? Is it going to be to our advantage to find the reactions at A and E to get started? I think so. You'll notice that if I do go to A and write a joint as equations of equilibrium at that joint, I would have 1 bar force, 2 bar force, and 2 reactions. So that'd be a horrible place to start. I could write 2 equations and 4 unknowns. That's not good. But if I can get these two reactions, now I can go to A, because I can write 2 equations and just 2 unknowns, so 2 bar forces. So it may not always be the case, but in this situation, finding reactions is going to be a good place to start. So let's do that. So I'm going to assume at E, I have a reaction in the Y direction. I'll call it EY. And then also at A, AY, and then in the X direction, AX. So let's find those reactions. So to find these reactions, probably a great place to do to get started would be to sum moments at A. Why? Why is it a good place? Yeah, 2 of my unknowns are concurrent there, so if I sum moments here, the only one that will cause any moment will be EY and the force. So let's start there. So I like to use right-hand rule for my sign convention. So let's sum the moments about point A and make sure it's 0. So let's start up in the front. Mr. McBride, how do we sum moments about A? Tell me the moment about A for this force EY. Is it positive or negative? It's positive, so it's EY, and what's the moment R?
4 meters.
4 meters. Mr. Street, what about the effect of the moment about A for this force P? Is it positive or negative?
Negative.
Negative, so the force is P, and what's the moment R? 8 meters. Everybody see that? That looks pretty easy. So it looks like EY is equal to 2P. Pretty good? So Mr. Brown, what do we do next? What would you like to do next?
You go around point B, draw your...
Well, what about, let's find all the reactions first. We just found EY. How do we find the other ones today? What else what other equilibrium equations? Yep, we could do that. So let's sum forces in the Y. Ms. Arriaga, what sum the forces in the Y for me?
AY.
Yeah, AY is up.
Plus...
EY?
Yeah.
And then, the force P, right? So what is AY? Remember, EY you plug in here is 2P. So what is AY? P, but is it positive or negative? Negative. Everybody see that? Students hate symbols, don't you? I like symbols. I can solve this problem for any P. I'm done. I can plug in whatever P I want. Isn't that nice? The power of symbolic reasoning. Okay, enough of that. So what are we left with? Mr. Robinson, what do we do next?
Sum the forces in the X direction.
Oh, you got the hard one. What are the sum of the forces in the X direction?
AX.
AX. So AX has to be 0. So we had 10 unknowns in this problem, and now we've found 3 pretty quickly with the free body diagram of the whole structure. So now we have 1, 2, 3, 4, 5 joints. We want to go check those till we can solve all the bar forces. Where would be a good place to start? Let me propose E. Let's start at E. Oh, Mr. Mabry's shaking his head no. Why? That's a bad place to start, isn't it? Because there's 1, 2, 3, 4 unknowns and 2 equations. That's not good. How about B and C? How about B? 1, 2, 3 unknowns, 2 equations. Still not good. How about C? 1, 2, 3 equations, 3 unknowns, 2 equations. Not good. So where's the best place to start? D would be a place to start even if I don't have the reactions. Why? 2 unknowns, 2 equations. Great. Also, don't be confused that this is a zero force member because of the case 1 we talked about previously. It is 2 forces connected at a point. However, it has a load. Okay? So that'd be a good place to start. So let's do that. I'll start at joint A. So let's draw the free body diagram of joint A. There it is.
We started A.
Oh, sorry. Let's not start at A. I said D, didn't I?
Yes.
That's a D, see? That's a D. Not an A. We'll edit this out in post-production. Okay, so we've got P acting down. Now I'm going to assume my forces in the bars. In tension, I have the force in DE, and in tension, I have the force in CD. Now, one little side note about my numbering system, I always just do this alphabetically. You may have been exposed to in the past that this order gives you like tail to head of the arrow. So this would start at point C and head to D. I don't follow that. Okay, we've already talked previously. I always assume tension, and I just put these in alphabetical order for keeping track of them. Also, what's this angle here? What is that? 60 degrees? Mr. Brown.
So if you think you can tell if it's in compression or tension, should you go with your, like, what you think? Like if you knew CD was in tension because of that force P.
My first thought on that is you do whatever you need to do to be correct. My experience has taught me that if you have to think extra about something as trivial as sign convention, that it will interfere with you solving the problem. So the way I solve it for myself is I always assume tension. I don't even think about it. Now when I apply my equations of equilibrium and I get positive and negative signs for that, then it tells me that I have tension or compression. I don't even have to think about it. Now I will look afterwards and say, does that seem to, correspond to the way I think the structure is going to behave, just to check myself? I do that then, kind of at the end, not at the beginning. I don't try to predetermine, this is going to be in compression, I better consider. I just think that's a little extra fog when you're trying to sprint through the exam. But again, number one, you do what's successful for you.
I was getting, myself confused. When you consider tension all being positive, even though DE and CD are both in the negative direction, are you considering those positive? When
You're mixing 2 pots together. One pot is, I'm assuming these to be positive for what? Axial force. Okay? I'm done with that. Now I'm going to write my equations of equilibrium. I can assume positive X and positive Y anywhere I want. Okay, so even though I assume both of these are tension forces, what are their X components if I assume right is positive? They're both going to come out to be negative. Does that mean they're negative forces? Only because I arbitrarily chose right is positive for X and up is positive for Y. That's completely arbitrary. These are not completely arbitrary. This is tension. You cannot choose another tension. You're stuck with it. The silence in the room is overwhelming. Does everybody see that? Because as we move forward, just a little preview for what's coming down the road, when we add other forces internally, like shear force and bending moment, they have sign conventions too, and I'm going to try to do the same thing there. Always assume positive. So let's say I've done that. So what do I do next? Who did I leave off on? Did I finish the front row?
Yeah.
Oh, Mr. McClanahan, what would you like to do next? We have two equations, right? We can sum forces in the x or sum forces in the y. What's the best choice? That's a good choice. Now, to kind of go back to what we said before, I'm going to assume up is positive. You don't have to do that. You can assume down is positive. At this point, it's completely arbitrary. Now, why do we start with the y equation first? Well, you'll notice that dE is only in the x direction. So only one force, CD, has a y component. So what is the y component of CD? That's right. So I'll have F CD sine 60, and it's acting up. What else is acting in the y direction with this problem? Minus P. So one equation, one unknown. Can I solve that? Yeah, what is CD equal to? But it looks to me like it's going to be positive. And I don't know what P divided by sine is. What's sine of 60? That's 0.866 or something like that?
Yeah.
What's 1 over at 0.866?
1.15.
1.15. Anybody else getting that? Yes?
Yes.
1.15 P. So now I know that since I got a positive result, then CD is actually in tension. Now, before going any farther, does that make sense? If I come out here and take D and pull it down, which direction do you think D is going to move? Up or down? Down. As it moves down relative to C, will that element get longer or shorter? It will get longer. Longer means tension. Okay, Mr. Stewart, you have the easy question. What do we do next?
Solve for x.
Yeah, how do we do that?
So the sum of the forces at x equals 0.
Right. So I'm going to assume to the right is positive. Again, this is an arbitrary thing. You can assume to the left a positive if you like. And you'll notice both our forces have what? Positive or negative components now? Negative. So Mr. Andrews, do that for me. What do you get?
So you got minus FD,
Right?
and then you got minus FDC, or FCD cosine.
Correct. Anything else? Nope. So we should be able to solve for FDE. And right away you can see that when I put this on the other side of the equation, I'm going to get a negative value. And whatever that is divided by the cosine of 60, which I believe is 0.5, so you're going to get what? 0.05, I don't know what it is. Somebody help me. 0.575?
Yeah.
And it came out to be negative. Does it make sense that DE is in compression? So what's going to happen to D? It's going to go down. You think it's going to move left or right? Probably to the left, which means that relative to E, this element will probably get a little bit shorter. That's why it's in compression. So I got 1, 2, 3, 4, 5 things, 5 to go. And just so that we can see it, I'm going to put a little squiggle through the ones that we already have. So what's next? Where would be another good place to go?
With squiggles around the other side, right? Joint D.
Joint D, yeah. Let's just for hypothetically, can I go to E? Now? How many unknowns at E now? 1, 2, 3. Not a good place to go. Can I go to C? No. 1, 2, 3 unknowns. Can I go to B?
Yeah.
I could go to B. There's only two unknowns now. So.
The squiggles are on joint D on those numbers.
Oh, I did it again, didn't I? I can't erase those, but I'll put those here. So yeah, like I said, you can go to joint C, but you can't go to joint B. But we want to get these two squiggles. How do we get those? Finally, we get to go to joint A. Whew. See? The fog of the solution. So now I'm going to draw my free body diagram at A. I'm going to apply my forces. AX was 0, AY was minus P. Now I assumed it was up, so what does that mean on the joint? It's actually down. Now some people say, oh, you're changing the direction. No, I didn't go back and change this. I'm drawing a completely new free body diagram, and I'm putting the forces that act on that diagram.
Is that not A1?
Yeah, AY is minus P.
Okay.
So I drew it as minus P. You see that? So now I'll assume tension in force, that's AE, and tension in force AB. And just like before, we know this angle is 60 degrees. You'll notice something about D and A. What's similar about them? They look almost the same, they're just kind of flipped, right? Horizontally. So the same strategy we applied at D, we can apply at A. So Mr. Deaton, what would you do first?
Sum the forces on the Y.
I think that's a great idea. Sum the forces in the Y. Mr. No, do that for me.
AB times sine 60.
Is that positive or negative?
Positive.
Right. So FAB sine 60, that's acting up,
Minus P.
minus P. Look at these two equations. They're pretty much the same. So I'm hoping that we'll find that FAB is equal to 1.15 P. Is that correct? So I'll put a little squiggle there because I found AV. All right, what's next? Mr. Fan, I'm sorry.
Sum the forces in X direction.
In the X direction. Okay, Mr. Monterey, do that for me.
So it'd be negative FAE.
Wait a minute. Both the X components are going right or left?
Right.
So they're
Positive.
positive. So would you say FAE? That's correct.
FAE plus FAB.
What part of FAB? The X component, right?
Right.
What's the X component?
Cosine 60.
Correct. And you'll notice these are pretty much the same except for the signs. Right? So when I solve for FAE, what do I get? I get negative, and I'm hopefully going to get 0.575. Is that what I got? Squiggle, squiggle. So now I'm caught up. Can I go to joint E now? I've been begging to go to joint E all day. Can I? Technically, yes, because there's only two unknowns. Would that be a good place to go? No, I still don't like that one. What about B and C? Are they now valid? Yes. Pick one. B? No? What's wrong?
Wait, I don't understand why E we can't go to, but B and C we can.
We can. We can go to any one we want. The reason I don't want to go to E is in the normal XY system, they both have X components and they both have Y components. So it would be two equations in, two unknowns. Traditionally, students don't like that. If you go to B, let's say, what do I have? I have one that's all X. This one has X and Y. So I can come here and solve in the Y direction, and I should be able to get BE. Now you'll notice that I'm going to have to include information I've already solved. So this is the downside of this method, is that it's going to incorporate previous results, and if you make a mistake earlier, it's just going to propagate. Okay? So let's go to joint B. So there's my joint B. And now I'm going to write my equations. So tension, I have the force in BC. Tension, I have the force in AB. And tension, I have the force in BE. And there's no applied load there. I'll go ahead and mark that this is 60 degrees, and that if I looked at a diagonal, this would also be 60 degrees. So I have my geometry. Now, if you just look at it this way, you think, oh no, this is not going to be good. I've got 3 unknowns, only 2 equations. But remember, we know AB. So I'm going to write the equations like I don't know AB, and then I'll plug back in. Okay? Now I know that this is the only unknown with the y component, so I'm going to sum forces in the what direction first? Y direction first. So I'll tip you off to that. So now, who am I left with? Mr. Scoopta, do that for us.
So the plus FBC, we're doing X direction, or Y direction.
Right.
So it'd be minus FBE, and then it'd be cosine of 60.
Okay.
Sine of
right.
60. And then AB also has a...
Is it positive or negative?
It's going to be positive. But no, it's negative at this point.
Okay, so negative FAB, and it's, what component is it?
It would be the sine as well.
Is that it? Well, that's not so bad. The sine 60s cancel, right? And it says FBE is equal to minus FAB, right? And if you look back, we solved for AB 1.15p, right? So that means that BE is minus 1.15p. Okay? Any questions about that? So what's left to do? Mr. Mabry, what do we do next?
Sum of forces of X.
Yeah, let's do that. Oh, Ms. Pinafore, you get the big one. Sum all the forces in the X for me.
Positive FBE.
Which one? F what?
FBE.
Okay, what's the X component of that?
The positive.
Yeah, but what's it? Are you taking all of FBE or just the X component of it? Which is?
Cosine.
Right. So we got FBE cosine 60. What else? What else is in the positive direction?
FBC.
Right. Is there something in the negative direction?
And then minus FAB cosine 60.
Correct. Now, just to remind you, we know BE and we know AB, right? So that means we should be able to solve for BC. And I'm going to have to let you guys do that for me. I'm thinking it's going to be in tension, so it should be a positive number. What is it? P. Anybody get an answer? Bueller.
2.3.
Bueller. What'd you get?
2.3.
2.3? Sounds high. Is it?
Got FBE, which is 1.15p, and FAB is 1.15.
Well, to solve for BC, one of them goes the other side as positive, one goes as negative. Right? Are they both? Is it 2?
Negative?
I could be, but I think it's going to be in tension. I don't know why I'm thinking that. No one's getting it? Am I going to have to plug stuff in?
If you plug in an E and a negative 1.15 P, so it'll be negative 1.15 minus negative 1.15.
Oh, that's right. They will. What is AB?
Negative 1.15.
It's negative, so it becomes positive.
No, it's 1.15.
Oh, it's just 1.15?
Yeah.
It is. Okay, so they will both go. It will get big. So what'd you get now?
2.3.
2.3?
P.
Right. Anybody else getting that?
That's 1.15 because negative times cosine of 60.
Oh, you do the cosine?
Yeah.
Cosine of 60 should be half, right?
Yeah, cosine of 60.
It should be half of everything.
So 1.15.
Oh, 1.15, yeah. You doubled it somehow. You forgot the cosine?
I canceled.
Oh, can't do that. So 1.15 P, and that should be negative, right? No, positive.
Positive.
Oh, that was not so bad. Seemed bad. Work.
Why can't you cancel cosine?
Well, if you divide everything through by cosine, you have to divide this by cosine too, right? So just you plug. It turns out that the values for each of these are 1.15, and then you take half of that and you add them together, you get 1.15 back. So what have I? What don't I have? I got this one, and this one. I got this one, and this one, and this one. I'm only missing CE. How can I get that? Can I go to E? Sure I can. Do I? No, I don't want to. I want to go to C. This truss is nice in that it's symmetric. So you notice when we go to joint C, it's going to look like B, but again, flipped over. So I'm still going to have the force in BC. I'm going to have my tension force that I assumed in CD. And I'm going to have the one thing I don't know, the force in CE. And I'm going to know these angles. And the same thing here. Just to emphasize it, this is the only one I need to be done. How can I get that? What's going to be the easiest one to do? Some force is X or some force is Y? Well, they all have X components, but only 2 have Y components. So I'm going to go with some of the forces in the Y. I'm going to assume up for my static sign convention, and summing forces in the Y direction. What do I have? Who do I leave off on? Ms. Higgins, do that for us. Yes.
And then
Sine 60, right? Now this one I can divide through by sine, and I'm trying to find CE, so it looks like FCE is equal to minus FCD. And what's FCD? Let me flip back. CD, we found it right at the beginning, 1.15. So this should be minus 1.15 P. And thank goodness we're done after almost 30 minutes of work. Whew. That's a pain, huh?
So now if you gave us P, we could just go back and multiply.
Plug in P. P is now 1 trillion pounds. What's the force in CD? 1.15 trillion pounds. And what is it? Is it in compression or tension? Compression. Is this a doable problem on the exam? I hope not. Because it took me 30 minutes to work it. Even without talking to you guys, I couldn't have done it in 15 minutes. It's just too much. That's 10 things to find. I had to write 10 equations. Think of that. That's 1.5 minutes an equation without any distraction and knowing what you're doing. So I would not think this would be an appropriate problem for you on the exam. So any questions about this before we move on? Okay.